I would like to continue on with some of the slides in our presentation. Typical uses for threads include programs that need to improve the performance with extensive input-output operations, like when working with databases and large files. Another situation is a server application, which must allow multiple users to execute their requests simultaneously. This can be a database server with multiple users running database queries, or a web server with an interactive website and multiple users accessing its resources. In our course, we're going to focus mostly on the responsiveness of a GUI application. Nearly all tasks with graphical user interface front end must execute in the background in order to avoid unresponsive user interface. Even if the user interface is frozen for just 1 second, it creates a very negative user experience. On average, one user makes hundreds of clicks per day, but of course gamers click much more often. Sometimes graphic designers click a lot too. So any noticeable delay in GUI is a major annoyance to all types of users. Therefore, we must know how to program JavaFX with background tasks running as background threads. Let's say a few words about these key methods of thread class, runnable interface, and the object class. Thread sleep causes the current thread to suspend execution for a specific period. This is an efficient means of making processor time available to other threads of an application or other applications that might be running on the system. So the sleep method can also be used for pacing the execution, like waiting for another thread to finish its work, just like we did with our examples of the timestamp printing or computing prime numbers. Of course, thread start grabs available operating system thread of execution and then makes a call into the run method. So in our example, we create the thread object, we specify the implementation of our runnable interface, and here we provide our overridden run method, and as soon as we call start, which is an object method of the thread class, the new thread will invoke the run method. So that's basically two of these methods kind of relate to each other very closely. There is other possibility to configure the thread object, and that is to extend the thread class and override its own run method. However, using runnable interface like we did in our examples is much more flexible, because our object could be extending other objects and implementing other interfaces, whereas extending the thread class is much more constraining. One common mistake to make is to start calling the run method, which is obviously the entry point for a new thread. Therefore, we never call the run method, we have to call start, which will do the call of the run for us. The implementation of a thread in Java is done as a state machine. So once the thread is created, it can be only in one state at any given time. So a thread can be in one of these states. New is a thread has not yet started. Essentially, as soon as we create this thread object, its state will be new. Runnable means that the thread is already executing inside Java virtual machine. Blocked means that a thread is blocked waiting for a monitor lock in this state. We will talk about locks and monitors later when we discuss the synchronize keyword a little bit later on. A waiting state indicates that a first thread is waiting for a notification from the second thread. Again, we'll talk about waiting and locks notifications later in our videos. And terminated is when the thread has already exited from its run method.